Today I'll talk about van der Waals equation of state. So first we must know what is van der Waals equation of state. So van der Waals equation of state is expressed as P is equal to RT by V minus A by V square, that is the van der Waals equation of state. Then here P is the pressure and V is molar volume. So P is pressure at ATM, V is molar volume liter gram mole, T is temperature in Kelvin, R is gas constant, that is 0.08206 atm liter gram mole Kelvin, and A and B, that is van der Waals constant. Now here we are taking one example here. So using van der Waals equation of state, compute the molar volume of ethane at 50 degrees centigrade and 50 bar. For ethane, critical temperature is given 305.3 and critical pressure is given 48.08 atm. Now for ethane or any gas, so A is nothing but 27 by 64 r square Tc square Pc, that is nothing but 0.42188 r square Tc square by Pc. B is 1 by 8 RTC by Pc, that is 0.125 RTC by Pc. Now data given, so temperature is given, and that is 50 degrees centigrade. So if we convert in Kelvin, that is 323.15. P is 15 bar. So if we convert into ATM, so 15 into 0.9869, so that is 14.8035 ATM, so means 1 bar is equal to 0.9869 ATM. Tc, the critical temperature is given 305.3 Kelvin, and critical pressure, that is 48.08 atm, that is also given, and R is it's 0.08206 liter atm mole Kelvin by mole Kelvin, that we know. Now if we flag that, so A is A 27 by 64, then R square Tc square by Pc, so we will get that A is nothing but 5.5073. Again similar way we can calculate B. B is nothing but 0.0651, and here we have to calculate that V ideal, so we have to take the reference point, so RT by P, so that is nothing but 1.7913. Now molar volume can be determined using a graphical procedure, or you can use numerical technique. So one way is that graphical procedure using the van der Waals equation of state. For that, the van der Waals equation can be expressed as f of V is equal to P minus RT V minus V plus AY V square is equal to 0. Now we have to find V where f of V is equal to 0. We can use the numerical technique also, so we can use any Newton-Raphson technique or bisection method, we can do that. So here for that we need to take at least 3 points, so if you take more points, so the graph will be good and we can easily get that particular V where FV is actually 0. So now we can take that V ideal is reference point, and we actually whatever that V points we are taking, so and if we plug and FV, so ultimately there should be sign change, and then after plotting that V and FV, we can easily get the value of V. Now here 3 values are chosen. You can choose as many as you wish to get better result, but the condition is FV sign changes. So V ideal is the reference point. Now we can plot V versus FV, which will intersect x-axis, and that point is the molar volume of the gas by using van der Waals equation of state. Now again, so this is FV is nothing but P minus RT V minus V plus AY V square. So now we have to find particular V. Okay, so now here we are taking V. So this is our reference point, and then we are just taking to that negative value, not negative value, so V ideal minus 0.1, V ideal minus 0.2, you can take as means you can take as your choice, as many as point. So now here you can say one is positive, this is negative and this is positive, so that is required. Even if you get here negative positive, that is also fine. So ultimately FB should be one negative and another is positive, that is required, and in between we will get that V molar volume of V where FV will be 0. Now we got, so V ideal here, V ideal minus 0.1, so we just reduce the V ideal and we calculate the FV. So V ideal minus 0 2, so we also calculate FB. So here it is negative signs, it is positive, and V ideal plus 0.1 and V ideal plus 0.2, so all are positive. Now all this point if I plot, so this is the negative and this is negative point and this is positive. Okay, this is positive, this is positive, this is positive. Now this plot intersect here, so that is nothing but the molar volume, so that is 1.63840. so molar volume is 1.6384 liter per gram mole. Means we need whatever volume is taking, that is not a matter, but obviously that V should be taken such as that FV should change its sign. Okay, otherwise we can't get the molar volume. So when that two positive and negative sign, so that will intersect that x-axis, and that x-axis will be that intersection point will be molar volume. So that final answer is that this one, V is equal to 1.6384 liter mole. That's it. Thank you.